Hello, welcome to one more sessions on econometrics. Okay, so in this we will discuss how to test or how to do or how to evaluate a regression results or how to evaluate the parameters of a regression that we have obtained through OLS method. Okay, so in last class we have discussed the normality assumptions. Okay, so in order to go further in all our evaluations, we assume that the normality of the distribution, okay, or the underlying distribution is normally distributed. Okay, then when we say that the normality distribution or the underlying distribution or the beta cap 1 and beta cap 2 is normal distributed with mean and variance. Okay, and we know that the mean of u is 0, so ui is a nid of 0 and variance, and we know that this ui, the mean of this ui is always equal to 0. Okay, but the variance is not 0 but a constant. Okay, then how we can find out the variance? We have said that when we discuss about these properties, we have said that the variance should be minimum. Okay, but how we can find out the variance? Okay, so that we will see in this video, in this first part of this video, and remaining part we will discuss some of the hypothesis testing procedure about various statistics which we have derived from the regression model. Okay, so variance is basically used to measure the reliability of accuracy of an estimator. So reliability, accuracy. Okay, in order to measure the reliability and accuracy of a estimator, we usually used to adopt or apply the variance test or standard error test. Or together this variance and standard error is known as statistical test. Okay, then in statistics, as I told you, the reliability is always checked by variance or its square root or standard deviation or standard error. Okay, so variance of beta cap 1 means what? Small sigma divided by sigma small x square. Okay, then its standard error is small sigma divided by root of sigma small x square. Then what is the small sigma? Small sigma is nothing but root of sigma u cap square or RSS divided by n minus 2. Okay, small sigma is equal to, small sigma is nothing but the standard error of the regression model. Okay, it is nothing but the RSS divided by n minus 2. N minus k means 2 variable. Okay, so since we are dealing with 2 variables, so k is 2, so n minus 2 root of RSS divided by n minus 2. Okay, so with this information it is very easy to calculate this variance of beta cap 1. Then how we can find out the variance of beta cap 0? For that we have to find small sigma square, okay, into sigma capital X square divided by n into sigma small x square. If you take the root of this, you will get standard error. Okay, so the thing is that the variance and standard error should be minimum as possible. If it is 0, then it will be highly precise even though it is not possible. Okay, so using the, in order to test the accuracy of a OLS estimator or a regression coefficient, we usually use to test using a standard error and variance. If the variance is very close to 0, then it is fine. Okay, yes. Then after this, after checking this reliability, okay, we have to test whether our slope coefficient is significantly different from 0 or not, or we have to do certain hypothesis testing about our interest. Okay, so in simple regression model we usually do a test called t-test. Okay, so before going for this t-test we have to specify the tail of the test. How we can specify the tail of the test? The tail of the test is based on how we can determine whether a test is one tail or two tail. It is based on the simple in alternative hypothesis. Okay, look at the symbol in alternate hypothesis. It is not equal to, then it means that two tail test. If it is less than or greater than, it means that it is a one tail test. If it is greater than, it is a right tail test. If it is less than, it is left tail test. Okay, so it means that in our previous example about consumption and income, what we have assumed, consumption and income are related. Okay, that means there is relationship between consumption and income, and there is no relationship between consumption and income. Okay, so in hypothesis what we usually do is, okay, we will assume a value, or we'll assume a null hypothesis in which it is assumed to be true in the beginning of the analysis. Okay, so a null hypothesis is a hypothesis that is believed to be true until it declared as false. So what we have to do, we have to assume that this beta 0 and beta 1, sorry, this uh, x and y are not related. So our null hypothesis will be beta is equal to 0, and alternative hypothesis beta is not is equal to 0. It means that there is a relationship. Okay, yes, then based on our theoretical things we can change this specification into greater than or equal to, or less than or equal to, whatever it may be. Okay, so I'm not going for that. So after this what we have to do is, we have to find out the t-test or t-value. How we can find out t-value? In regression, t-value means what? T means beta cap divided by beta cap 1 divided by, or beta cap 0 divided by standard error of betas. That means if you want to find out the t of beta 0, then it means that your beta 0 value divided by your standard error of your beta 0. Okay, then, or if it is beta cap 1, then beta cap 1 divided by standard error of beta cap 1. This is the t-test or t-value. Okay, then its table value we can find out from any of the table, any of the t tables. Okay, or you can find out from the some of the softwares, and then you can compare. If actual t value is greater than the table value, you reject the null hypothesis. Okay, so this is the hypothesis about the t-test. Okay, so t-test is used to test the individual significance of the parameters beta cap 0 individually and beta cap 1 individually, separate. Okay, then if you want, in multiple regression model there may be more than 2 or 3 independent variable. There you can check the significance level jointly. For that you have to use f test. Okay, yes, then you can also use confidence interval test that I'm not going to discuss with you, okay, because that's not so important. Or you can use p-value approach. Okay, so what's p-value? P-value is the smallest level of significance at which a null hypothesis can be rejected. Okay, so this is basically the probability of committing a type 1 error. Okay, so it's also you can find out from using its equations. Okay, so I'm not going for that too. Next, the very important thing is the goodness of fit of the model. How we can find out the goodness of fit of the model? Okay, whether the fitted model is good or bad, how we can test it? Okay, so as you know that the aim of the regression analysis is to explain the behavior of the dependent variable in terms of independent variables. Okay, so the total variations in independent variable may be due to the variations in x or maybe variations in error terms. Okay, so you can say that some variations in y can be explained by the regression, and some variations in y cannot be explained by the regression. It is explained by the residual sum square. Okay, so the coefficient of determination or goodness of fit or r square, okay, it is the most commonly used measure of goodness of fit of the model, or how well our sample fit the regression line. Okay, so r square is just basically uh, how much proportion of the total sum square is explained by the regression line, or how much percentage of the total variations in dependent variable are explained by the independent variable, or that the measured regression line. Okay, so its equation is r square is equal to sigma y cap minus y bar square divided by sigma yi minus y bar square. Okay, so this sigma y cap minus y bar square is called ess, and sigma y minus y bar square is called rss, sorry, tss. Okay, so if you find out sigma y minus y bar square, it is TSS, total sum square or total variations in the dependent variables. Okay, then after finding out the y cap, you just subtract y bar from each y cap and square it. It is known as ESS. Okay, then r square is nothing but the ESS divided by TSS. Okay, or ratio of the explained sum square to total sum square. Okay, or you can find using the RSS also. That means sigma u cap square divided by 1 minus sigma u cap square divided by sigma y minus y bar square, or 1 minus RSS divided by TSS. Okay, it is nothing but if the total variations is in 100 percentage. Okay, the regression line can only explain the 80 percentage, then remaining 20 percentage is explained by the other factors. So RSS is in total 100 percentage, only 80 percentage are explained. Okay, so the value of RSS will be 0.8. Okay, or 1 minus 20 divided by 100, it is also 0.8. Okay, so a value for r square, or a value that value beta cap 0 and beta cap 1 that minimize the RSS will be automatically maximize the ESS, sorry, maximize the r square. Okay, so since the measuring the r square is based on the RSS. Okay, a beta cap 0 about beta cap 1, the value of the estimators that will minimize the errors. Okay, so that value will automatically maximize the r square. Okay, and this r square value is non-negatives. It can be 0, it can be 1, or it can be in between 0 and 1, but it will be never become negative. Okay, and the r square value is always lies in between 0 to 1. 0 means perfect, 1 means perfect fit, and 0 means what? No any single percentage of variations in dependent variable are not explained by this, or cannot be explained by these independent variables. Okay, yes, so that's all about the r square. So r square is a measure of goodness of fit of the model. It will tell us how well the sample fit the regression line. How we can find out? It is finding out using total variations, estimated variation, or from RSS or residual sum squares. Okay, so it means that total deviations in dependent variable is a sum of the estimated sum square plus RSS, residual sum square. Okay, then R square is ESS divided by TSS, or 1 minus RSS divided by TSS. Is it okay? Yes. Now, in your syllabus, one more part is there, that is the multiple regression. Okay. So, in simple regression, as I told you, there will be only two variable, one independent variable and one dependent variable. Okay. But the thing is that in practically many situation, we may not be able to explain the dependent variable using one single variable. So what we have to do, we have to include many other variables. Okay, so if there are more than one variable or more than one independent variable, it is known as multiple regression model. A multiple regression model is a regression model where there are more than one independent variable. Okay, so the most important case of a multiple regression model is three variable model. Okay, one dependent variable and a two independent variable. Okay, and the thing is that when we have more than three variables, okay, then it is very difficult to find out the parameters or beta 0, beta 1 or estimators using the calculator or using the Excel or using some other pen and notebooks and also. Okay, so it will be very difficult. You look at, assume that there are three variable, y, x1 and x2. X1 and x2 are independent variable. How you can find out the value for this? Beta cap 1 means sigma x1 y sigma x into x sigma x2 square minus sigma x2 y into sigma x1 x2 divided by sigma x1 square into sigma x2 square minus sigma x1 x2 whole square. So this is a very big equation. Okay, similarly you can find out the value for beta cap 2, and also if you subtract these both equations, this both equation multiply with its independent with its x1 bar and x2 bar from y bar, you will get these intercept also. Okay, but the thing is that doing this operation or doing multiple regression manually is very difficult. Okay, so I'm not going for that. You understand that this is the equation for the estimator in a multiple regression model, and multiple regression model was first used by R. Benini. He was an Italian statistician in 1990. Okay, yes. So all other things will be remain just like the simple regression model. Okay, hypothesis testing and everything will be depends on, will be similar to the simple regression model. But thing is that only one thing will be different. That's interpretation. Okay, in multiple regression, when we interpret one slope coefficient, we have to keep the other coefficient as the constant. Okay, for example, if consumption depends on income and wealth, okay, then where consumption income coefficient is 0.5 and wealth coefficient is 0.25, then we can interpret it as a, if 1 unit of income increase, okay, the consumption will be increased by 0.5 unit, keeping the effect of wealth as constant. Similarly, when the wealth is increased by 1 unit, okay, the consumption will be increased by 0.25 unit, keeping the effect of his income as constant. Okay, so in multiple regression model, the slope parameters are known as partial coefficient or partial slope coefficients or partial elasticities. Okay, yes. Similarly, All other things, precision of the model, or variance, standard error, hypothesis testing, and everything will be same except t-test. Okay, here we can also test the individual coefficient using t-test, and also we can test the joint significance using f-test. Okay, and when we come to the goodness of fit, in multiple regression model we won't use the r square, because r square is a non-decreasing function of your independent variable. That means if you increase the independent variable number, then your r square will be automatically increased. So what you have to do, you have to adjust your ess and tss, or rss and tss, with degrees of freedom. That means n minus k and n minus 1. Okay, so if you adjust your r square with degrees of freedom both in numerator and denominator, it is known as the adjusted r square, or alternative coefficient of determination. Okay, so that's all about the multiple regression model. Okay, so in the session on econometrics we have discussed what is econometrics, the methodology of econometrics. In that we have discussed in detail what is the econometric model. Okay, then we discussed what is regression and how it is different from correlations, what is conditional mean and unconditional mean, what is prf and srf, and what is the objective of the regression, what is OLS, how to derive the OLS estimators, how to estimate the, how to find out the value for this beta 0 and beta cap 1 using example. Okay, then we have seen the assumptions of OLS, the properties of the OLS, then we have seen the normality, the test for the normality, then we have seen the testing the precision or the accuracy of an estimator. Okay, then we have seen checking the doing hypothesis testing, especially t-test and f-test. Then we have seen the p-value approach. Okay, then goodness of fit of the model, or r square, or and multiple regression, then multiple r square and multiple adjusted r square. Okay, so I hope that I have discussed everything about each and everything in detail about or from the topics that there in the syllabus. Okay, then after these things there is a topic testing for some linearity, something like that. Okay, so it is nothing but testing for linear means, or the method for linear means correlation and regressions. Okay, so this correlation and regression are the two powerful method to test the linear associations between certain variable. If you want to test the direction and the degree, you can go for correlation, or if you want to test the cause and effect relationship, you can go for the regressions. Okay, so I hope you have enjoyed the class, and if you have any doubts, you can personally contact me. Okay, or you can contact the Alches, and I wish all the best success. Okay, yes, and I would like to suggest you that if you have not mathematically very powerful, very knowledgeable person, don't go for this equation and all. You just understand the concept and you prepare a small note. Okay, descriptively. Okay, that will help you out in answering the questions properly, since the questions are in descriptive mode. Okay, then you have to answer the thing in very short way. Okay, so you prepare your own note using this my class and my presentations. Okay, so once again I wish all the best success for your exam and future career. Okay, thank you very much.